Today, we are going to be reversing the previous lesson. So I'm going to give standard form numbers and ask you, what is it in scientific notation? So essentially, we need to know, okay, where do we need to drop our decimal point? And how many places would we have to move it to get it where we want it? And also, when we write this in scientific notation, should the exponent on the 10 be positive or negative? So, let's tackle this. Now, I'm going to copy the problems just so that I've got more space to work with. So this first problem is the number 800,000. First thing we need to know is where do we want, well, okay, I lie. First thing we need to know is where is the current decimal point? This being a whole number, it's on the end. The real question, though, is where do I need the decimal point to be? So this requires us to understand scientific notation a little bit. So I'm going to scroll back up, and I want to make sure I get a couple of yesterday's problems on here. So all of yesterday's problems were already in scientific notation. What's special about them? Where's the decimal point, if there is one? It's after the very first thing that isn't zero. So in number 53, 2.29. In number 54, 6.9. In number 55, 3.3. In number 56, 4.2. We want to put the decimal point so that there is one number in front of it that is not zero. So where is that in this number? It would be after the 8. There is now one number to the left of my decimal point that is not zero. So I know where the decimal point is. I know where it needs to be. Question is, how many times would I have to move it to get it there? 1, 2, 3, 4, 5 times. So 8.00000 is just 8 times 10 to the 5th power. We moved the decimal point 5 times. Now, how do I know that's a positive 5? Because I moved the decimal point to the left. And yesterday, when I moved the decimal point to the left, that meant it was negative. And there's two ways we can think about this. Yesterday, the exponent was a direction on what to do. Today, we're figuring out the exponent based on what we did. And since that is the reverse, we have to think about it as being reversed. So if we choose to move the decimal point left, it's actually a positive exponent. If we choose to move the decimal point to the right, it's a negative exponent. The easier way is look at your original number. If your original number, 800,000, is bigger than 10, your exponent's positive. If your original number is less than 1, as in number 58, your exponent will be negative. So let me show you number 58. Again, I'm going to copy the problem just so that I can write things much more neatly. We see this decimal point. It's right there, clear as day in front of us. But on its left is a 0, and I don't care about zeros. I need there to be something that isn't 0 to the left of my decimal point, but only one digit on the left side of 0. So that means I need to drop my decimal point between the 7 and the 6. If I put it after the 6, then I would have 7 and 6 on the left side of the decimal point, and we can't have that. It must be strictly one digit. So now, how many times did we move it to get it there? 1, 2, 3 places. So we're looking at 7.6 times 10 to the negative third. Negative because we chose to move the decimal point to the right, or because the number is less than 1, whichever of those reasons makes sense to you. And 3 because we moved it 3 places. At this point, this is the idea for conversion from a standard number to scientific notation. So I invite you to pause and attempt the remainder of today's problems, which would be through number 64. And here we go. We have 0.73. I need the decimal point to be between the 7 and the 3 so that there's one digit on its left side. To get it there, I have to move it one place. So I have 7.3 times 10 to the negative first. In number 60, the decimal point currently has 0 to the left of it. I have to move it all the way to the end to get something other than 0 on the left side of this 3. That is 1, 2, 3, 4, 5 moves. So I have 3. There's nothing after the 3, so it's just 3. Times 10 to the negative fifth. In 77, there's an invisible decimal point on the end. There are currently 2 7s on its left side. That's too many. So I need to put it between the 2 7s, which is a move of 1 spot. This means I'm looking at 7.7 times 10 to the first power. In number 62, our decimal point needs to drop in after the 5, so we have 5.09. To get it there, we have to move it 1, 2, 3, 4, 5 times. So we have 5.09 times 10 to the negative fifth. Notice real fast, I'm not dropping anything. After I move the decimal point, I have 5.09, and I write 5.09 in my answer. Decimal point in number 63 needs to go between the 7 and the 4, which means it must move 1, 2, 3, 4 times to get there. 7.4 times 10 to the negative fourth. And finally, in number 64, we need to put the decimal point between the 1 and the 2 so that only a single thing is to the left side of it, the 1. It would require us 2 moves to make that happen. So we have 1.2 times 10 to the negative second.